Hello students, in previous lecture we had discussed about finite automata. What is finite automata? What is definition of finite automata? So we have discussed all those aspects of finite automata. Then we moved into deterministic finite automata. We had picked definition of deterministic finite automata, and we had picked various design problem of finite automata, deterministic finite automata, that how to design any deterministic finite automata or DFA. Now, in today's lecture, we are going to focus on NFA, or in various books, it is also written NDFA, and that is non-deterministic finite automata. Non-deterministic finite automata. Now, as we had said earlier that we had some determinism. Now, what do we mean by non-deterministic? Non-deterministic says that now machines have that capability that by taking certain one input, it can traverse into several states. So once again I am repeating, by taking any one input from one state, it can traverse into several states. So machine have that capability, or machine have that guess power, that by using that guess, it can move into various states. I'm sure you have played various games. For example, uh, there is one puzzle game which says that uh, you will get jackpot uh, once you will click the right door. Now in front of you, you have five doors. Now which door contain that jackpot? So it's a total guesswork. Every door looks same. You need to click one door at a time. So what you will do, you will click one door. If you get failed, you will click another door until unless you get the right door. So that is guesswork. And this is non-determinism, that you actually machine don't know exactly that what is exact path. So it works on the guesswork. So that comes under non-deterministic finite automata. So as I have said, the transition from a state on an input symbol can be to any set of state. Now the thing is, uh, if I take one example of it, so what would be the example and how it can work? So it's simple that there is one state Qx. By taking one input A, what I can do, I can move into Qx state or I can move into Qy state. So I have two choices to move. Now, when it becomes finite automata, once we have all five tuples, so now since by taking A, I can move into two or more states or multiple states, this becomes an FA. So how it works actually? From initial state, what you will do, you will pick particular input and you will move further. Please make sure, since we are discussing finite automata, and finite automata have only one initial state. Always finite automata have only one initial state. So we'll start from one state and will move to the final state by checking all the sequences and choices as per our input. So this is the way or non-deterministic finite automata works. Now let's take one example to pick that how our choices work. Now suppose this is one chess. Now here, suppose this is my starting state and this is my ending state. Now what are the my inputs? My inputs are that I can move either in black ones or I can move into the red ones. Now suppose I have chosen one sequence of input that is red, black, black. Now rule says that what I can do from any state I can move into only adjacent states and one at a time. So I can choose any one depending upon the color of it. Either it is red or black, whatever sequence is given. So suppose one sequence is given red, black, black, and it was asked that is there any possibility to move to the final state if I choose this red, black, black. So how to proceed it and how it contains the non-determinism. Now since it is red, so what are the adjacent uh, states we have and which are red, it says 4 and 2. So there are two possibilities, 2 and 4, where I can move if choice is red. So here we got one guess. Now I don't know which one is the correct one to achieve or to move to the final state on the basis of this sequence. So what I'll do, I'll traverse further since next one is given black. So from 2, what are the black adjacent values? That is 1, 3, 5. So I have 1, 3, 5. Now from 4, what are the adjacent values which are black? That is 1, 5 and 7. So since I have 1 already, I'm not going to write again. 1, 5 is already here. I have incorporated 7. Now I have 1, 3, 5, 7 where I can be if I'll choose 2 or 4. So I can be in these particular states depending upon the choice of the previous one. Now if I have again B sequence that I need to go to the black states. Now from 1, which one is the black state? That is 5, 5. From 3, what is the adjacent black state? 5, which is already given. From 5, what is the adjacent black state? That is 1, 7, 3, 9. 1, 7, 3, 9. From 7, what is the adjacent state? That is 5, which is already incorporated. So if somehow I'll reach into the 5 by taking B, means if I am either in 2 or 4, since both have next adjacent is 5, so what I can have 1, let's write this, 1, 2, then 5 and then 9. Or I can have 1, 4, 5, 9. So I have two possible paths by taking red, black, black to move into the final state. Here comes the non-determinism. There are other paths also. If I choose those paths, then there is a possibility that I will not reach to my final state. So I hope you got uh, the concept that how guesswork actually perform the task. So that is non-determinism. But please make sure non-determinism does not say with respect to any machine that you can have everything wrong which can become right or right become wrong. It says that yes, you have multiple paths to reach, but if the string is right, if that particular thing is right, then you will have at least one path out of n number path to reach into that final state. And if string is wrong, then out of those n number of paths, you will not have even a single path to move into the final state. So let's move further. So how to define NFA? So what was the definition of DFA? Or what is the definition of FA? It says it has five tuples. Now what are those tuples? Says set of state, set of input, transition function, initial state, and set of final state. Non-deterministic finite automata is also a finite automata. Hence, it also consists all five tuples: set of state, set of input, transition function, initial state, and set of final state. So, how it is different from the DFA? Is there any difference between the NFA and DFA with respect to definition? Apart from that non-determinism, can we identify the difference between DFA and NFA? In non-deterministic finite automata and deterministic finite automata, the only difference comes with respect to this function, transition function. In deterministic finite automata, transition function says that by taking any state and corresponding input, I can move into one state. By taking any state and corresponding input, I can move into one state only. That is for DFA. Now, NFA says that by taking certain state and corresponding input, I can move into the power set. Means any combination of those states. I hope you are aware about power set. So that is the primary difference between DFA and NFA. And you need to be aware that every NFA can be converted into DFA. Once again, I am repeating, every NFA have one equivalent DFA. You can convert every NFA into DFA. So I hope uh, it is clear that what is non-deterministic finite automata, what is non-determinism in it. So in next lecture we will pick that why actually we require non-deterministic finite automata. We have done deterministic finite automata. Here we have picked that every NFA have DFA. Then why we actually require non-deterministic finite automata? So we'll discuss that thing into our next lecture.